Hello to everyone and welcome to the IEI High School SAT class. My name is Vincent and I am one of the SAT math coaches here at IEI High School. We will have some time concentrating on the math section with our problem-based learning teaching method. That means that we will have some theory and then we will have some exercises of the 63 topics Dr. John Chang presents in his book SAT Math 5th edition. Before we jump into our first topic, that is linear functions, I'd like to share a couple of tips on how to manage this section. So the reason behind these two topics is that I've seen too many people not taking into account how important time is on the SAT. The first tip is to remember to bubble in the choices at the end of both math sections. I highly recommend taking 2 minutes at the end of each section to bubble in the choices. For example, in the third section, the non-calculator one, you have 25 minutes to solve 20 questions. So what I would do is to remember that once I have solved all the questions, then I have to take 1 to 2 minutes to fill out the answer sheet. The second tip is to get used to having a watch. You cannot get stuck on one problem. If you cannot solve a problem, then leave it and at the end go back to that question and try to solve it again. All of this while you take a look at your watch and see how much time you have left. You can take a look around every 5 minutes at your watch. But do not constantly look at your watch because you can lose some time and get frustrated and distracted. So we will apply these two tips throughout our preparation for the SAT math questions. Let's take a look at our first topic, which is linear functions, and see how we can solve a couple of examples related to this topic. So let's take a look at this slide. It says that the functions are called linear because they are precisely the functions whose graph in the xy plane is a straight line. So if we look here at the graph, we can see a line in the plane, and we also can see 2 points in the same line. And if we want to mathematically represent the line, we can use a variety of different forms, starting with the slope-intercept form, which is as follows. This is f of x, that is also y, like we see on the nose chart, equals m times x plus b, where m is the slope and b is the y-intercept. That is the value of y when x equals 0. Then we have the point slope form in which we can get the slope with two known points, and x1 and y1 are usually the known points when we want to get other points. Our third form is the general form that is sometimes asked when getting the answer in an exercise. You can get to know the right general form by plugging in the point in a line and see if the equation can be solved. Finally, we have the standard form that can be related to the general form. Remember to read the question carefully and see what kind of form they are asking for. We have seen that the slope of a line appears in two of our four forms, right? So, what is exactly the slope of a line? We can define it as the change in y values divided by the change in x values. It helps us get an idea of how the line looks like because it measures how steep a line is. It can be represented by this equation, delta y divided by delta x, or difference in y divided by the difference in x. You can calculate the slope with two different lines. Before we move on, let's look at the notation of a point. So, in the function, we have the point x, y, or x, f of x, since we already know that f of x equals y. And if we look at the example, we can see that f of negative 3 equals 5. Then we can get a point that would be negative 3, 5. Now that we know all the theory behind linear functions, let's take a look at this first question. Our first step would be to read and understand the problem. For a linear function f of 0 equals 2 and f of 3 equals 5. If k equals f of 5, what is the value of k? So we have some information and it can be useful to identify the three different points mentioned on the problem. First, we have f of 0 equals 2, or as a point we can represent it as 0, 2. Second, we have f of 3 equals 5, or as a point we could represent it as 3, 5. Third, we have f of 5 equals k, or as a point we can represent it as 5, k, right? So these points help us better understand the problem and identify the x's and y's. So I think that the first thing we could do is to get the value of the slope with the two known points. In the theory, we mentioned what is the value of the slope with some terms, and it can be represented as the slope being equal to delta y divided by delta x. Or in other words, we can say that it is y2 minus y1 divided by x2 minus x1. In this specific example, 3, 5 can be our x2, y2. So we can put right here x2, y2. And 0, 2 can be our x1, y1. Any of those 2 points can be either x1, y1 or x2, y2. At the end, you will have the same answer, that is the slope of our line. Now we can actually plug in the numbers and we will have m equal to 5 minus 2 divided by 3 minus 0. That is 3 divided by 3, or just 1. So now we can try to work with our slope-intercept form and plug in the values that we know. We then have, let me use another color, y equals m times x plus b, right? We then have y equals m. We know the value of m already, that is just 1. So instead of putting m times x, we can just put x plus b, right? In order to get the value of b, we can get back to the definition of the y-intercept, that is the value. Let me put here what is the y-intercept. That's another concept we already know. Intercept. We are trying to work with the y-intercept, that is b, right? So what did we say about the y-intercept? That it is the value of y when the line intercepts the y-axis. In other words, the value of y when x equals 0. So from our point 0, 2, we can actually get to know the value of the y-intercept. What would it be? We know that the y-intercept equals 2, right? Because it is the value of y when x equals 0. So we now have other value. Now we have another equation, and it comes to be y equals x plus b, and we already know the value of b, and it is just 2. So now we just plug in our value of x that the question is asking for. And what is the value of x? We can get back to the question. The value of x equals 5, right? So we now can put y equals 5 plus 2, and the value of y will be 7. So that is the value of y when x equals 5. But the point 5, 7 will be equal to 5, k. So our final answer comes to be k will be equal to 7. Now let's look at other type of questions. So in this next question, let's just read it. If f is a linear function and f of 3 is 2 and f of 5 is 6, what is the y-intercept of the graph of f? Like in our previous problem, we can identify the two different points mentioned before. First, we have f of 3 equals 2, or as a point we can represent it as 3, 2. Second, we have f of 5 equals 6, or as a point we can represent it as 5, 6. In order for us to continue working on this problem, let's just remember what is the formula of the slope. It was m equals delta y divided by delta x, and this being equal to y2 minus y1 divided by x2 minus x1. 5, 6 can be our x2, y2, and 3, 2 can be our x1, y1. Now we can actually plug in the numbers and we will have the slope being equal to 6 minus 2 divided by 5 minus 3, that is 4 divided by 2, and finally we know that our slope equals 2. So now we can try to work with our slope intercept form and plug in the values that we know. Let's just remember what is the slope intercept form, and it is just y equals m times x plus b. But remember that we already know what is the value of the slope. So our equation comes to be y equals 2 times x plus b. In order for us to get the value of b, that is the y-intercept, we can plug in one of the 2 points we know. Remember that we have 2 points at the beginning of the exercise. Let's just try with 3, 2, this point. So in the case of 3, 2, we will have 2 equals 2 times 3 plus b. That is 2 equals 6 plus b. If we subtract 6 of both sides, we can put here minus 6 in parentheses, minus 6 in parentheses. We will have the value of b being equal to negative 4. And if you want to make sure that is the right answer, you could work with the other point, that is 5, 6. So our final solution to this problem comes to be negative 4. Now that you have seen what a linear function is, and a couple of examples of how to put into practice the theory mentioned at the beginning of the video, now your job is to continue practicing what you learned today. Remember to subscribe to our YouTube channel if you want to continue learning about the SAT. You can leave your questions in the comments below. We will answer them as soon as possible. Thank you for being here. I'll see you in our next video.